Welcome to Kanerika's podcast, The Digital Shift. Let us address a frustrating reality you have likely encountered the moment you try to bring artificial intelligence into your modern data engineering workflow.
Yeah, it is a very common wall that teams hit almost immediately.
Exactly. You deploy a sophisticated general AI coding agent, you give it a highly specific prompt about your enterprise data, and within seconds, it generates this pristine, beautifully formatted SQL that just looks flawless on your screen.
Right, it looks perfect until you actually try to use it.
Exactly that. The moment you actually execute that query in your environment, it completely fails. I mean, the code compiles, sure, but the table joins are entirely wrong, the role-based permissions are ignored, and it references columns that were deprecated, 3 years ago.
And then you end up spending more time untangling the AI's hallucinations than you would have spent just writing the code manually from scratch.
Which completely defeats the purpose of the automation.
It really does. And that failure loop is the fundamental gap in enterprise software development today. Those general agents are relying purely on pattern matching from their vast public training data.
Right, they are just looking at public repositories.
Exactly. They understand the syntax of SQL or Python perfectly, but they are entirely blind to your organization's unique, messy reality.
They just do not know your specific table structures.
No, they do not. They do not understand your internal governance policies, and they certainly do not know which data pipelines are currently broken or under maintenance. They are basically guessing at your context based on how the rest of the world writes code.
Well, the mission for our deep dive today is to examine the solution to that exact problem. We are talking about Snowflake CoCo, which was formerly known as Cortex Code.
Yeah, CoCo is completely changing the approach here.
It really is.
Yeah.
Our objective is to analyze the true, measurable impact of this tool across the enterprise data stack. We're going to explore how it mechanically operates, what the financial realities of running it actually look like, and the strict security implications you have to navigate.
Along with how it compares to other heavyweights in the artificial intelligence space.
Exactly. We are covering the full spectrum of its capabilities to give you maximum value without getting bogged down in unnecessary minutia.
So to truly understand the impact of CoCo, we really have to examine how it solves that blindness we just described. The critical differentiator here is deep context awareness.
Right. It does not just sit on top of your database.
No, it actually integrates directly into the metadata.
Yeah.
Before CoCo writes a single line of code, it actively reads your team's actual Snowflake catalog.
Which is huge.
It is massive. And it maps the data lineage, meaning it traces the path of your data from its origin to its current state, just to ensure the upstream data it wants to query is actually fresh and reliable.
And it goes beyond just the data structure too, right? Because of the security aspect.
Exactly. Most importantly, it reads your role-based access controls, your RBAC. It mathematically verifies what the specific person making the request is actually permitted to see.
So it knows who you are before it answers.
Right. Only after establishing that factual, real-time baseline does it draft a plan to answer your prompt.
I think about the difference this way. Using a general AI agent is like taking a brilliant, classically trained chef and dropping them into a pitch-black kitchen.
Oh, that is a great way to look at it.
Right. I mean, they know exactly how to cook a 5-star masterpiece, but they have absolutely no idea where your specific pans are kept. They cannot see what ingredients are actually stocked in your pantry.
So they might accidentally grab the salt instead of the sugar because they're fumbling around in the dark.
Exactly. Snowflake CoCo, on the other hand, is like a chef who walks into the kitchen already knowing exactly which cupboards hold the right ingredients, which knives are properly sharpened, and, exactly who in the dining room has a peanut allergy.
The context is already established.
Right. The final output changes completely because the environment is fully understood before the work even begins.
That is a highly accurate way to visualize the mechanics. And because it possesses that environmental awareness, CoCo goes far beyond just acting as an autocomplete tool for code snippets.
It is actually writing structural code.
Right. It generates production-ready SQL and Python scripts. It builds DBT models, which are those complex analytics engineering transformations that turn raw data into clean business logic.
And it handles the scheduling side too, right?
Yes, it writes airflow DAGs to keep those data pipelines running on schedule. It even generates Streamlit apps for front-end data visualization.
That is a massive operational surface.
It is, and we can look at the performance gains through a specific metric rather than just theoretical promises. There is a documented case of a custom skill being used specifically for DBT performance tuning.
Oh, the runtime optimization case.
Yeah. The agent analyzed a complex model, understood the underlying data structures, and optimized the logic so effectively that it slashed the model's runtime from 10 hours down to under 2 hours.
I really want to pause on that metric for a second because dropping an execution time from 10 hours to under 2 hours is massive.
It is an incredible efficiency gain.
Mechanically, how is it actually achieving an 8-hour reduction in compute time? I mean, a standard autocomplete agent simply cannot do that.
Well, it achieves that because of the lineage mapping we discussed earlier. A general agent might look at a 10-hour query and just try to clean up the syntax a bit.
Right, maybe format the joins better.
Exactly. But CoCo looks at the query, reads the catalog, and realizes that the developer is initiating a massive, daily, full table scan on a data set that contains billions of rows.
Which is incredibly expensive.
Very expensive. Because the agent knows the architecture, it recognizes that an upstream table is actually partitioned by date. So it rewrites the developer's logic to only process the incremental daily delta, just the new data, rather than scanning the entire historical archive.
So it solves a structural architecture problem, not just a syntax problem.
Exactly.
Saving 8 hours of compute time directly impacts the bottom line, which transitions us into an essential part of this equation, which is where CoCo actually lives, and the new economics of AI context.
Yeah, the operational and financial side is where this gets really interesting.
Right, because now that we understand what the tool can do mechanically, we need to look at how development teams physically interact with it. There are 3 primary operational surfaces you need to know about.
Starting with the native interface.
Exactly. First, you have Snowsight, the native browser interface. This is where your team handles everyday administrative tasks, answers quick governance questions, or writes SQL directly in the web console.
The second operational surface is the CoCo desktop application. This is a native local environment featuring an integrated terminal and a full code editor.
And this is where the cloud agents come in, right?
Yes, the standout architectural feature here is what they call cloud agents. These allow developers to run multi-hour tasks, like that massive dbt build we just mentioned, completely unattended in a managed serverless container.
So you do not have to keep your machine awake.
Exactly. You can trigger a massive compilation, your laptop can go to sleep, you can even disconnect from the network entirely, and the cloud agent will just finish the execution asynchronously in the background.
That is incredibly convenient. What is the third surface?
The third surface consists of the command line interface, the CLI, and standard IDE integrations. You can operate CoCo directly inside VS Code or through an official plugin for Claude Code.
So you can stay in your preferred environment.
Right. This allows engineering teams to bridge their existing local development tools with a live, context-aware connection to their cloud data environment.
Well, interacting with those specific surfaces brings us to a major shift in how this technology is actually monetized. The initial free preview period has officially ended.
Yeah, that transition just happened.
Snowflake has moved to a token-based AI credit-building model for both Snowsight and CLI usage. But the economics of this billing model are absolutely fascinating.
The caching mechanism changes everything.
It really does. From the second conversation turn onward, repeated context, such as your conversation history, the schema definitions, or the specific files you're actively working on, is served from the cache at roughly 1/10 the normal input price.
And that implementation of the caching mechanism completely changes the financial math of using artificial intelligence in the enterprise.
How so exactly?
Well, if an engineer opens a session, asks one isolated question, closes the session, and then repeats that disjointed process 10 times throughout the day, the company is paying the premium, uncached input price every single time the agent has to reestablish the environment's context.
So they are getting penalized for short interactions.
Exactly. But if that same engineer keeps a single continuous session open to work through a highly complex multi-step pipeline issue over several hours, the caching kicks in. The system remembers the schema and the previous steps, which drives the overall token costs down dramatically.
You know, this raises a really interesting question about behavioral engineering. If caching makes longer, sustained sessions dramatically cheaper, Snowflake is essentially subsidizing long-term problem solving.
That is exactly what they're doing.
Does this fundamentally force developers to change their core psychology? I mean, for the past few years, we've been trained to treat AI like a highly advanced search engine. We ask a quick question, we get an answer, and we close the tab.
Right, the Google search mentality.
Yes, but this new pricing structure mathematically penalizes that behavior. It forces developers to treat the AI less like a search portal and much more like a dedicated long-term pair programming partner.
You are watching a real-time behavioral shift engineered entirely through pricing. Developers are heavily incentivized to build a shared, ongoing context with the agent over hours rather than minutes.
And I imagine finance teams are watching this very closely.
Well, absolutely. Finance and platform administration teams are monitoring this adoption because the cost ultimately rolls up into daily AI service credits.
Is there a way to control those costs from spiraling?
Yes. To prevent runaway departmental spending, administrators have the ability to set independent daily credit limits for CLI usage versus Snowsight usage. So, if a developer aggressively hits their local CLI cap for the day, they are not entirely locked out. They can still access Snowsight for lighter tasks.
That is a smart failsafe.
It is. But the organizations seeing the best return on investment are the ones proactively training their engineers to maximize that cached context window.
However, all of this incredible context awareness, the automated pipeline optimization, the cost efficiency of the cache, it all relies entirely on one massive underlying assumption.
And that is a very big assumption.
Right. It assumes that your enterprise data environment is actually organized and governed in the first place. If your data estate is a chaotic mess of undocumented tables and broken schemas, the AI is just going to confidently automate that chaos.
It cannot read a catalog that does not make sense.
Exactly. And this brings us to how we at Kanerika ensure that prerequisite foundation exists before an agent ever touches the data.
That foundational readiness is the core philosophy we at Kanerika operate by. An artificial intelligence agent is only as intelligent and only as safe as the data estate it sits on top of. Modernization simply has to precede automation.
You cannot just skip to the fun part.
No, you cannot. CoCo is an exceptional tool, but it cannot magically fix undocumented schemas. It cannot make sense of orphan tables that have not been queried in 5 years.
Or those weird manual workarounds people build.
Right. Most critically, it cannot magically repair manual reconciliation logic that relies entirely on the institutional knowledge held by one specific analyst in your finance department. If you point a high-speed automated agent at a fundamentally broken foundation, you just arrive at the wrong answer exponentially faster.
That is exactly why we at Kanerika focus so heavily on the rigorous modernization phase before we ever layer AI on top of a client stack. We utilize our Flip migration accelerator to rebuild that exact foundation.
Flip is absolutely crucial for this step.
It is. What Flip does is automate the complex pipeline conversion and validation process. When we are migrating legacy on-premise systems to modern cloud platforms, Flip actually reduces the manual migration effort by 50 to 60%.
And the timeline reduction is incredible, too.
Yeah, it allows us to complete highly complex migration projects in just 2 to 8 weeks.
I really want to emphasize the mechanics of how Flip actually achieves those timelines, because reducing a massive enterprise migration down to 2 to 8 weeks requires deep, deep automation.
It is definitely not just a search and replace tool.
No, not at all. It is not just doing a basic text find and replace on old code. Flip actively parses the abstract syntax tree of the legacy SQL, translates the underlying logic to modern cloud-native syntax, and then automatically generates side-by-side validation queries.
Just to prove it worked correctly.
Exactly. It proves the new pipeline matches the output of the old one perfectly. To put the impact of that into perspective with a concrete case study, we at Kanerika recently helped a client who was struggling with regional systems that operated completely independently of one another.
Oh, the silo problem.
Yes, their monthly reporting cycle required massive amounts of manual, spreadsheet-driven data reconciliation just to figure out what was true across those regions.
The manual reconciliation you're talking about is the absolute bane of data engineering. When you have analysts downloading CSVs, writing these complex VLOOKUPs, and trying to manually match mismatched IDs across different regions, it is a nightmare.
It is incredibly inefficient.
Right. So we moved their entire data state to Snowflake and completely rebuilt their reconciliation logic on governed, centralized data. The metrics on that specific transformation show exactly what a clean foundation achieves.
The numbers on that one are fantastic.
They really are. By establishing that governed environment, we saw a 60% reduction in manual data reconciliation. The data reporting cycles became 40% faster, and the overall delivery of analytics to the business was 3 times quicker.
You only get those types of exponential results when the underlying foundation is completely solid.
Exactly. Once that is established, specialized tools like CoCo can actually deliver on their operational promises.
So moving from that foundational requirement to the broader market reality, we have to look at the competitive landscape. Once you have that strong governed data foundation in place, how does CoCo actually stack up against the general purpose market leaders that most developers are already using?
That is a question every CTO is asking right now.
Right. And just as importantly, what are the real-world enterprise security risks of deploying an agent with this level of deep architectural access?
Well, let us examine the benchmark battle first. In ADE bench testing, which is a framework that specifically measures accuracy in complex analytics engineering tasks, CoCo scored 72.1% accuracy.
That is a very solid score.
It is. In comparison, both Claude Code and OpenAI Codex scored 65.1%.
So a full 7-point advantage.
Exactly. That 7-point gap in accuracy is highly significant in enterprise engineering, but it also explains a major operational trend we're seeing right now. Teams are not simply firing their general agents to use Snowflake's tool. They're actively running two of them side by side.
Yeah, deploying multiple agents is rapidly becoming the standard best practice in the industry. It is all about utilizing the right tool for the specific domain.
Like having different specialists on a team.
Precisely. Enterprise engineering teams will frequently run two separate agents in their daily workflows. They use CoCo for deep internal Snowflake context, where it completely dominates the benchmarks because of its native awareness of schemas, lineage, and metadata.
And then they use the general agents for the rest.
Right. Simultaneously, they use Claude Code or GitHub Copilot for broad repository software engineering, UI refactoring, and general code-based management outside the database itself. You use the general agent for the wide application view and the specialized agent for the deep, complex data work.
That makes perfect sense. But deploying these highly specialized agents introduces strict security realities that absolutely must be addressed. We discussed earlier that CoCo reads and respects existing RBAC and masking policies, operating securely under the Snowflake.copilot_user role.
Yes, the native integration handles the permissions.
But I want to push back on this premise slightly. If this tool flawlessly inherits a company's existing role-based access controls, doesn't that just mean a company with a messy, overly permissive legacy security setup now has an AI moving at light speed to potentially exploit those exact vulnerabilities?
That is exactly what it means.
Right. I mean, if a junior analyst accidentally has access to the payroll tables because of some old permission slip-up, the AI now has access to the payroll tables on their behalf.
You have identified the exact security paradox that enterprise architects face today. The artificial intelligence only respects the boundaries you have explicitly drawn.
So if your boundaries are wrong, the AI is wrong.
Exactly. If your access controls are overly broad, if you have historically given standard data analysts read access to highly sensitive, personally identifiable information due to some legacy oversight, the AI will efficiently and happily utilize that access to answer their prompts.
It just assumes you meant to give them that power.
Right. The agent basically acts as a powerful amplifier for your current governance state. It magnifies your architectural strengths, but it fiercely exposes your hidden security weaknesses.
And the vulnerabilities extend far beyond just inherited permissions inside the database, too. There are critical technical exposures regarding how the tool physically runs on a machine, particularly with the command line interface.
The local environment is a major concern.
It is. Because the CLI runs directly in your local desktop environment, it has the potential to expose plain text credentials and AWS access keys that happen to be sitting openly in your shell environment. Professional security reviews have explicitly highlighted this local environment access as a major risk factor.
And this is why enterprise security teams cannot treat the CLI as just a standard run-of-the-mill application installation. You simply must implement strict Docker containerization for the CLI environment.
To isolate it from the rest of the machine.
Exactly. You have to sandbox the application away from your core operating system files. Furthermore, strict network egress controls are an absolute necessity here.
What happens if you do not restrict the outbound traffic?
Without those network restrictions blocking outbound traffic, a prompt injection attack becomes a severe threat. Just imagine a scenario where a malicious command is hidden inside a standard CSV data file that the agent is instructed to read.
Like a Trojan horse inside the data itself.
Exactly. That hidden text could manipulate the agent into scraping those plain text AWS keys from your local environment and transmitting them silently to an external, unauthorized endpoint.
That is terrifying.
It is a massive risk.
Those security parameters are entirely non-negotiable. And it is exactly why the deployment of this tool is currently heavily restricted by Snowflake. As of right now, it is strictly prohibited from government, virtual private Snowflake, and sovereign deployments.
The compliance standards for those environments are just too high right now.
Right. If you are operating in highly regulated environments like defense or healthcare, the default sandboxing is simply not considered sufficient without the additional rigorous architectural protections we just detailed.
Implementing this technology requires a highly mature approach to enterprise deployment. The capabilities are incredible, but, it is not magic.
It still requires human discipline.
Absolutely. It demands rigorous engineering discipline, both in how your underlying data is structured and governed, and in how your network boundaries are strictly enforced to prevent data exfiltration.
Well, to summarize our analysis for you today, CoCo represents a fundamental paradigm shift for data engineering teams. It successfully transforms conversational natural language into highly accurate, context-aware engineering outputs that drastically reduce compute times.
It is a massive leap forward.
It really is. But that incredible power comes with a strict, undeniable mandate. It demands rigorous data governance and a thoroughly modernized, tightly secured data estate.
Which is the core foundation you have to build first.
Exactly. And that is the core of what we at Kanerika deliver for our enterprise clients. We build these secure, high-performance foundations from the ground up, and then we deploy specialized natural language agents, like our proprietary agent Carl, directly on top of governed platforms like Snowflake.
The integration of deep context AI into the data stack is no longer a theoretical exercise for the future. It is executing multi-hour, highly complex engineering tasks today. But your long-term success with these tools is entirely dependent on the discipline of your data management and the resilience of the security architecture you place around these agents.
I want to leave you with a final thought to explore on your own as you evaluate your own data stack. Consider the rapid trajectory we are currently on. As specialized AI agents can now perfectly map, deeply understand, and autonomously query our structured enterprise data based purely on conversational natural language, well, how long until the very concept of a human being writing manual SQL becomes a historical artifact?
It is a fascinating question.
It is. Will we soon view typing out select star from table the same way we view a switchboard operator physically plugging in telephone wires to connect a call? We're not just witnessing a simple change in our software tooling. We might be watching the definitive end of an entire coding language's daily relevance for the human engineer. Thank you for joining us on The Digital Shift.